Alright, section 11.8. We're going to be covering systems of linear equalities. It's a small section. We've gone over graphing, so if you remember graphing, then this will not be too difficult for you. So here we have these two inequalities, and we want two ordered pairs. So since they have it in standard form, it's going to be best to find the intercepts. So with the first equation, we have 2x plus 5y is less than 10. Alright, so I'm going to find the x-intercept, which means y equals 0. So if I plug a 0 here, this term, 5 times 0 is 0. That gives me 2x, I'm just going to say equals 10, because I just need the point, and then divide by 2, and that gives me x equals 5. So as an ordered pair, x is 5, y is 0. So we get the ordered pair 5, 0 for this first line. Alright, we're going to find the y-intercept. Alright, so this time x is 0. So if I plug a 0, 2 times 0 is 0. The term goes away. We just have a 5y equals 10. Divide by 5, and we get y equals 2. So as an ordered pair, x is 0, y is 2. So we get the ordered pair 0, 2. Now this inequality, the fact that it doesn't have a line meaning equal to, will give us a dotted line. So that's part of what they ask. So the first linear inequality, we're going to have a dotted line, and that's because this inequality is strictly less than. If it was just less or greater, dotted line. Alright, we got two ordered pairs, 5, 0 and 0, 2. So with that, it will graph the line for us. And then we will do a test point. So notice 0, 0 is on one side or the other. So if I take and I plug 0 and 0 in, that will give me 0 is less than 10. And this is a true statement. So we always shade toward the true side, and that means I'm going to be shading below in this region A. Alright, now for our second equation, is just an x equals negative 3. So this is greater than or equal to, so it does have a line. We're going to have a solid line this time. Now x equals 3 or negative 3. Let me go back and make sure I'm saying x equals 3. Negative 3. 1, 2, 3. So this right here, x equals 3. All along this line, I can pick any point I want to. Okay, as long as x equals 3, I'm going to get a vertical line here. So the y is going up and down, y is changing, but x is staying on 3. We're not going left and right anymore. So when I have to put points here, all I need to do is make sure x is negative 3 and x is negative 3. You can literally put a fraction, a decimal, anything that you want. So just to drive that point home, I'm going to put 0.1. Oh, they don't want you to do decimals. Let's do a fraction. Let's do 5 over 2, and let's do negative 1. Okay, it doesn't matter what you pick, it will work, just as long as you make sure x is negative 3. That's the description. Now it says x is greater than or equal to negative 3. Imagine this inequality like an arrowhead pointing to the right. So it's telling me to shade this side. As long as your variable is on the left hand side, this inequality will point left or right, the right direction. And also you can kind of read it. It says greater than, so more than, numbers bigger than negative 3 will be to the right. So we will be shading section C. Alright, now step 3 wants us to find points that satisfy both. Okay, so 1 we were shading to the right, and then we were shading down. So the section that's going to overlap is this section A here. What you can do is you can pick ordered pairs and see if it satisfies both. So 0, 0 again would be easy enough to do, and so you would do that for both. So one of them we already have 0, 0, that was true, and then for the x was greater than -3, we would say 0 greater than or equal to -3. And yes, 0 is to the right of -3. Here's -3 here, and as we go to the right, we're getting bigger. So yes, 0 is greater, and 0, 0 falls in that section. So if you wanted to test it by hand, you can do that. Otherwise, just kind of envision the shading, how we shaded it. That's kind of not right, but we shaded to the right, and we shaded down below this line. So the part that has the double shading across and down would be this section down here. So that would be A.